the first chapter. So where we left off at our last time was with the observation that this is a little bit of an elaboration on the book, that anytime you're observing something, there's a theory already inside of it. You observe things with expectations. And because your generation has invented sex, ideas involving sex are somewhat front of mind. And the example here was that when people first were looking at spermatozoa underneath a microscope, they saw little people inside, mainly because formism was the dominant method of science at that time. And you might think that that's just a funny example of antique science the way it used to be. But as you are a consumer of psychology, you should also be aware of the theories that you have. So for a while, when I was a younger person, I worked in a children's unit. This was back in the days when the state of Iowa funded mental health a lot better than they do now. And a lot of the children were behavior problems. The thinking of some of the people in that setting, they were very behaviorist. They saw behavior, they didn't like it, we need to condition on it. That from the theory of behaviorism made some sense to do, but actually for some of these children, they had medical conditions. They were unregulated diabetics. They had some minor forms of epilepsy. And it was these behaviors that were generating these causes that were generating the unwanted behaviors. And actually, people were not seeing the clues to insulin shock, to epilepsy, because they didn't want to see them, because their theory was, this is how I'm going to manage these kids. This talks about, from a larger standpoint, the value of a multidisciplinary approach when you use applied situations. So if you're working in social work, if you're working with groups of people, it's a good idea to have a social worker in the room, a psychologist in the room, perhaps a psychiatrist, perhaps orderlies, nurses who have been in a position to do a lot of observation. Have them sit around the room and talk about the issues, because sometimes what we might see as a behavior problem is a family problem, a medical problem, a psychological problem, a socialization problem, of that particular child within the classroom. In much the same way, larger issues, if you're going to talk about pure research, for example, the idea of alcoholism has been an area that I spent a lot of time in. Alcoholism is not just a psychology problem. It's a medical problem, it's a political problem, it's a social problem, it's a family problem, heaven knows, and it's a personal problem. And when you're making observations, having these different observers around is helpful in making that kind of an observation that will be productive. So it's important to talk just a little bit about how we solve problems. And Karl Popper had a 4-stage model of problem solving. And the very first thing is to have an old problem or an expectancy that's violated. I bet you can think of some times where your expectancies are violated. Coming to Missouri, perhaps, is going to violate your expectancies. These teachers don't behave the way that other teachers do. As a matter of fact, they're not behaving at all like high school teachers do. And the first reaction, if you're like me, is, well, that's just plain wrong. I hate that. They're supposed to be on my side. They're supposed to be the teachers. And it's also probably the case when you go into college that the success strategies that you use in high school don't work anymore. Because again, high schools or high school classrooms, you've got access to a lot better student-teacher ratio. And high school teachers are a lot more accessible than faculty at a university are. In high school, you could say, well, I'm going to get up next to this teacher and work with that teacher to solve the issues that are going on. And in return, that teacher is going to like me and help me. And in college, gee, a lot of them don't do that. I mean, some of them, I'd like to think I'm one of them that does it more than most, but the university environment is a different thing. The second stage, that's fundamentally what a problem is. And you can think about this, in a more general fashion. Everybody comes into a situation with expectancies. If you want to cite an extreme example, a baby is born into the world with expectancies. That's just how we are hardwired. That baby expects to be fed and comforted and cared for. You might say we're born with expectancies. The next stage is you generate tentative theories. You do things. A baby cries, it moves around, it does things out there. Or if you're going back to the college student example, you can have tentative theories about what's going on. You could say, my tentative theory is this instructor has an ego the size of a small planet, and to the extent that I can feed that ego or feed that person back the opinions they have, then I'm going to do well in the class. There are other theories out there, mainly that you as a learner are in a fundamentally different place in college than you were in high school, and that the tasks of college, of thinking critically, of maybe disagreeing with someone, but yet respecting their point of view and the reasons that they base their point of view, that's another theory you can have. Hopefully you generate a lot of tentative theories, because those come in useful for the third stage, where you eliminate some theories. A baby who is born finds out that, moving your left leg and waving your arm around is not productive in getting attention, but crying is. Or you try a few things in a classroom. You say, well, I'm going to ask the professor what she thinks, and then I'm going to write that down, and that's going to work on the test. Sadly, probably that strategy might actually work in some college classrooms. Over the course of time, some of the theories that you make are going to be less damaged. They're going to be the theory you're going to move forward with. And at the end of that day, you end up with a theory that's maybe the least worst in the whole situation. But it's also important to note then that you end up with a new problem. Sometimes, like a college student, now that I'm done with college, and now that I have my degree, what do I do now? How do I go into the business world? Can I just take my success strategies from college and use those in a new job? Or what things that I have from college are going to help me generate new tentative theories about how to go on with this stage in my life? So that's kind of a simple 4-stage model of problem solving. You could even say an amoeba, a one-celled organism, has a problem. It needs to have nutrition. So it kind of puts a pseudopod out, kind of moves around this way and that in an effort to find food. Some moves work, some don't. The moves that do work get it food. And now your amoeba has moved over a little bit closer to maybe a food source. Sorry, person to admit. Okay. So more generally, this 4-stage problem-solving model is how we do science. We try some actions and theories. We start with a problem. We go, hey, this isn't explained. This is a little bit hard to understand. I'll make some observations. I'll make some theories. And then the important part is that we have to kill off theories. That's what makes it science. It's not the amount of data you have. It's not how often your studies have been replicated that makes it science. Let's think of an example of something that's not science if we go back to the demarcation problem. For example, astrology. Astrology has centuries of data. The problem is that astrology is not falsifiable. I can't say, well, I read my horoscope today and oops, it was wrong. Or any time that an astrologer does make a prediction and it doesn't come true, they say, oh, well, Leo was in his cusps and therefore we didn't quite see what we wanted to see. They make a patch to it. I also mentioned the issue of Marxist theory, that at the end of the day, even though early Marxists thought the revolution would start in Germany because it was industrialized, it had a proletariat, whoops, all of a sudden Lenin arose in Russia. And we had to patch up Marxist theory to say, oh, well, that's because he was an exceptionally strong leader. And that's why the revolution happened there. We kill off those theories. That doesn't mean our theory is true. It's the theory that we carry forward, though. Now, that's kind of a neat and tidy story. So let's talk a little bit about some of the problems. The spotlight model is one problem. We tend to look for explanations that are similar to the explanations we already have. So the imagery here is, if you have a flashlight and you're shining it on a wall, or you're looking around in a dark house, you see you're trying to make an explanation there, and if the thing you're looking for is on the other side of the street or the other side of the room, you're probably not going to find it because you're busy shining the light at the part where you have been shining the light. So we're looking for explanations that are similar to the explanations we already have when we look at, say, caring for children in a children's unit. Maybe there are some kids who just have a behavior pattern that you could put them on a reward schedule and you can fix it. That doesn't mean that all of your kids are the same. The second problem with science, and this is a point that the book really doesn't talk about, is there's really no recipe for success. I can't give you a recipe or an algorithm that would say, and this is how you make a good theory. So, the two problems on this slide are, you don't know if where you're looking is the right place that you should be looking. And you're not really even quite sure as to how to move your flashlight around or how to come up with a theory that's going to be a satisfactory idea. Now, as we go into chapter 2, I'll talk a little bit about how we can maybe answer some of that. The third problem is that in that schematic that we'll get to later in this lecture is, what happens if the data don't fit the theory? They must be discarded. Do I say, this is just bad data, I need to fix my experiment? Or do I say, I have found something out about my theory, and we don't have a clear idea often as to where to go? Maybe it's just the data. Maybe it's just messy. Well, maybe, but maybe not. So one of the problems that we've known since the 1700s is there's something messy about the planet Mercury orbiting the sun. It doesn't behave the way Newton's theory of gravitation said it would. It's always a little off. So between the 1800s and early 1900s, we just said, oh, Mercury just goes around the sun in some funny way. But when Einstein's theory of relativity came along, all of a sudden we can use that theory that says there's this huge thing called the sun. It's got a lot of gravity on it that explains all of this unexplained error. So what became messy data now becomes something that we can fix in light of a better theory. For those of you who might think relativity theory doesn't have a lot to do with your life, well, a lot of you have cell phones. The satellites that orbit the Earth are regularly adjusted to account for the fact that the orbits of satellite around the Earth those models do not take into account the gravity of the Earth. So we regularly adjust our satellites in response to Einstein's relativity theory. So, killing theories. Imre Lakatos, fascinating guy, could have been prime minister of Hungary had the communist revolution not happened. Notice that, theories don't just exist in a vacuum. There might be something about a theory that's a core belief, and there might be some little protected belt of hypotheses that I could change so that it will fit to the data. So if you're going to design an experiment that's going to kill a theory, you not only need to have the data not conform to the theory in order to kill it, you need to get at some of the core assumptions of that theory in order to kill it. How do we know when we've got these little side ideas of hypotheses that protect our theory? How do we know when we have too many of them? And when we're making our theory, when we're making our tests of experiments, how are we going to design our tests so that all this little wiggle factors and side issues don't preserve the life of the theory? I want to talk just a little bit about other, those are sort of the side issues that I would get into chapter 1 in explaining to you about how science works, mainly because the first chapter is, to me, a little more too congratulatory of science. But these 4 norms of science that Merton mentions bear some comment because, I agree with those. So know these terms, put them on your flashcards. They will be on the test, as well as some of the other terms like falsification and scientism that you'll see earlier. Universalism. Scientific claims are evaluated on their merit, independent of who's doing it. So housewives can submit articles to journals just as much as
Car alarm is going off and I have to evacuate the building.
Okay, I'll talk with you about that afterwards. This is one of the reasons why many journals have you anonymize the paper before you send it in. They don't want to know that it's somebody at some university, and they don't want to know your name. The second one is communality. The information you have should be available and should be out there. Now, the book talks a lot about open science and making repositories of data available, and we should do that where we can. Some of the problem that's involved here is that they're reporting on data that are sensitive. So when I do alcohol research at Missouri, for example, we get a certificate of confidentiality so that no one can subpoena the questionnaire because, we ask young people, have you been drinking? And if so, how much? And have you ever driven while drunk? And, you don't want a lawyer coming in and subpoenaing that information to convict people, because then people would perhaps not be as likely to participate in your study. Disinterestedness. Scientists strive to discover the truth, whatever it is, and supposedly we are not swayed by conviction, idealism, politics, or profit. When you submit an article these days, you do have to submit a conflict of interest form to certify that, no, you are not actually making money off of the conclusions of your paper. Convictions and idealism, that's a little bit harder to look at because you went into this area of research because you wanted to do something. One of the problems that I was involved with when I was doing a postdoc at Penn State was the issue of childcare. Was it harmful to children or not harmful to children? There were implications for working mothers or working families in making that determination. And people quite openly came into that research with convictions that they had. The last one's my favorite, organized skepticism. You should never believe your own press. You should never say, now I crossed the line, I've definitively proven this. You should always take the point of a reasonable skeptic of your conclusions and think about what other explanations could be advanced for your theory. We talked about this last bit, that science can be basic, where we're simply interested in the bottom line questions, understanding something about per people. Translational research that takes a basic finding and then seeks to apply it. And on the far right-hand side, applied research, where we evaluate the implementation of that translational research. And these are three topics that you'll find out, kind of carry forward into the rest of the chapters in the book. So we'll probably want to have that down. If you've done the inquisitive already and looked at their questions, as I mentioned, the translational research items begin by saying, and this is a theory that is applied to X, and that's translational as opposed to applied research, which is just program evaluation. How do we make our work public? Well, there's a few ways to do this. One of the ways that, and this is kind of presented in order of importance, you submit it to a journal. And the reason you submit your work to a journal is reviewers and editors will look at your work and basically try to knock it down and evaluate it very critically so that you can say it has passed some kind of review. We cannot necessarily march to the conclusion of a given author just because they've written a paper. You can also present your work at a conference, and that's an informal way of going to somewhere and telling people about your work you're doing and getting feedback from the larger community. It also helps to advertise a little bit. And finally, you can publish a book. So I published a book on statistical methods. Publishing a book is a little bit of a gray area. Generally speaking, books don't count as much toward scientific progress as journal articles because editors and publishing houses will send your book out for review, but it generally doesn't go through as critical of a review. I mean, you're there to fix glaring errors in what's going on. Research doesn't happen in a vacuum. I have a couple of stories to tell about that, where research I've done has gone out into the media. And there are benefits and there are risks of journalism coverage. So let's talk a little bit about benefits. To the extent that the public at large or legislators can understand what you're doing, that's good for psychology, it's good for research. It communicates to, say, legislators why it is they might want to fund the National Institutes of Health or the Department of Education. You need to think a little bit when you're reading journalist articles, is this story important? Is it actually going to have some implication for how I live my life or how people in society live their lives? The accuracy of reporting is kind of an issue. The book talks about, warning signs for a journalist article. Scientists now know. Scientists prove. Or just a blanket statement of what we should now do. And when you're reading a journal article, think about how complete is it? Because a lot of times we don't see the rest of the study that's even being done. There have been times when, let me think of an example from my own life. There was an article that came out when my daughter was young that said, if you leave a child's light on in their room, they'll have bad vision. And she was used to having a night light on. We said, I'm sorry, we've got to turn this off at night. Big, huge argument. It was correlational research, though. it turns out that, generally speaking, children with poorer eyesight tend to want to have that night light on more than children with good eyesight, for whatever reason we could speculate about. But it wasn't a controlled experiment. You'll also see, especially in these days, an awful lot of work that's produced on the internet. So scientists sometimes do blogs, or they tweet their results, or they'll have an article and they'll publish it on something called a preprint server that just puts it out there for people to read. And it's okay to read that. Sometimes you'll get some ideas about whether scientists disagree about a particular point by reading these things. But it's important to keep in mind that it might not be as definitive as claimed on the internet. This last semester, I worked with a student on a scale of how people use the internet. I was kind of surprised that we don't have very much psychology scale development in this area. And we did a halfway decent paper on that and are in the process of submitting it. It's helpful to be skeptical. So that basically covers chapter 1. Are there any questions about what you have in that material, or the key terms? And I guess it's also okay to say, are there any questions about the last lecture as well?